Okay, let's get started. I'm going to talk about Android and audio plugins and State of Union. It is an attempt to replay my technical session at Audio Developer Conference Japan 2026. And since ADC tends to delay the publishing of recorded section video a few months, which is not acceptable, so I decided to record it my own and publish it by myself. Anyhow, so Android is missing common audio plugin formats unlike desktop. On Windows or macOS or Linux, we have VST3, LV2 or CLAP plugins, and on macOS we have Audio Unit V2 or V3. On iOS we also have Audio Unit V3, and even on web platform we have WebClap or Web Audio modules. They are experimental formats, and I'm not sure how much progress they are making, and they plan them seriously, but they are at least there. On Android there's no such a plugin format, so it's kind of a sad state. What happens if plugin formats don't exist on a platform? On macOS or iOS, we can use Audio Unit so that any DAW can expect other instruments of effector plugin applications available, and they are usable within them. And for instruments and effectors, they can just publish their instruments or plugin applications to iOS App Store or Mac App Store, and those DAW users would download those instruments, and then there are some markets there. Any DAW user can buy their instruments and effector plugin applications. On Android, there is no such an ecosystem exist. So if a DAW vendor wants to publish the application, they have to include all the instruments and effects bundled within the application itself. And for instruments developers, I'm not sure if there's any market for them. AAP is my experimental plugin format, and it tries to resolve this kind of issues. AAP is audio plugins for Android. It used to be simply Android audio plugin, but due to some trademark concern, I renamed it to this name. Any name that begins with Android could be claimed by Google. So AAP is an experimental plugin format and implementation that is designed to work on Android platform, and you can use any DAW with any plugin that support Android and AAP, and they can be any combination and they can be distributed by different packages. And AAP can show some plugin GUI such as Jetpack Compose or any Android view such as Juice GUI or even Web UI. I support it as well. And I have ported some plugins and host applications from desktop LV2 applications or Juice applications. And for LV2, I created AAP LV2 library, and for Juice, I have created AAP Juice module so that the existing applications can be easily ported to AAP ecosystem. The screenshots below is just an excerpt from my androidaudioplugin.org website. And there are already a handful of plugins. What we discussed through this session is that I would explain what kind of features we could already achieve on Android and how we can realize those features. But I'm not going to talk a lot about how to use AAP, which is too personal. I'm explaining more general stuff so that anyone can build any similar plugin formats by themselves. And I'm not going to talk a lot of details about Android AAP API. But still, I will explain what kind of features and abilities AAP ecosystem provides or it doesn't so far. This is not a typical Android audio development talk in that I'm not going to explain a lot about how to build a C++ application using Android NDK with Java and Kotlin. I'm not going to talk about Oboe, the audio API, not about how to integrate MIDI, not about how to build Android app GUI for your DSP based on Android View or Jetpack Compose. If you are curious about these topics, there are already some ADC sessions from the past, and there were some Google Android audio developers or advocates who gave the session talk, such as Don Turner or Phil Buck, so you would like to check them instead of this session. Okay, let me show you some demo. I'm not sure how it goes, but it would hopefully work. Excuse me, I'm adjusting the demo screen. Okay. So this is an experimental application that I'm building for desktop but ported to Android. It is called UAPMD and it is basically a plugin host. It looks more like a DAW. I intended to, but not really intended to build a DAW because it's a lot of work. So okay, let me show some plugins that's in action. This is a plugin called Dext, which is a popular Yamaha DX7 emulator. I think I need to restart this application, or okay, the audio is here. You can control GUI, and also you can select the presets, and they even from the GUI they are changed. And you can even look up parameters and you can see how they work. For example, let me switch to another tone. The parameters has changed. You can also control the parameters from the host GUI and it's reflected on the GUI itself. Or if you control the parameters on the GUI, it is reflected on the parameter on the host side. So the basic things work. Let me show you another example plugin. This is a popular synthesizer called Surge XD. And you can select some presets. You can use that Surge XD as well. Let me show you more advanced plugin. This is another Juice plugin that I ported to AAP. which is called Wavetable. By default, it's full, but you can select some professional sounds. The GUI looks like something like Sarah. This works really cool, and you can get some realistic sound. Okay, let me go back to the slides and I continue talks. I had some video recordings, and I have actually published some on YouTube. So if you are curious, you can check my YouTube account. I mean, from this video, and find my YouTube account to find more recordings. And the host application is hosted on GitHub at Sieno/UAPMD, so you might want to check that too. Let me go back to the slide. So let me talk about the plugin format. So I asked the question, do you think designing a plugin format is cool at the ADC conference? And some people actually raised their hands, but my intention there was like, say, it shouldn't be regarded as cool because designing more interface means like people have to support more API, which is a burden, and people want to avoid that. But since on Android there's nothing, so I had to do it anyway. So what is audio plugin format? Basically, audio plugin format is an interface, API, or protocol or something like that. Plugin format itself is not an SDK, in that its first priority is to preserve ABI backward and forward compatibility. And ease of development is just a nice to have feature. Everyone kind of thinks that CLAP is a cool API and it's easy to work with, and I totally agree with that, but it's not the first priority. VST3 is sometimes compared to CLAP and criticized like it's not really easy to deal with. I mean, even compared with VST2. And maybe that's true, but it doesn't matter in terms of ABI compatibility. The VST3 covers the most important features that it has kept for more than 20 years, I think. Not more than, it's almost 20 years since its first release in 2007 or 8, I think. So it's the most important feature is ABI compatibility. Anything else is in lower priority. And it must be kept in CABI or some more generic level, and it has to ensure real-time safety. So even if Java bytecode or .NET assemblies are ABI stable, they cannot really be used for audio processors because their runtimes are usually not real-time safe. The scope of the API should be limited to the interaction between the host and the plugins. We tend to have more and more features in the API, but having more features means like they have more API burden for backward to keep backward compatibility. So it's harder to evolve once you defined them. A related question is that should a plugin format API specify messaging between the plugin DSP and the plugin UI? And based on the last item, the answer should be no. And Elevator says yes actually, and the CLAP is like no, like it doesn't define anything. The reason why Elevator says yes is like they have different principles that the DSP and the GUI should be implemented and employed in different dynamic libraries. So they need some communication format together to communicate for each together. In terms of that, an interesting format here would be a web clap, which where the DSP lives in the audio worklet and the GUI lives in the main browser DOM thread. So they need some messaging format as well. So next topic is, who should design a plugin format? Who is this Atsushi guy? Is he working at Google? No, and this is just a hobby developer. And in terms of that, Apple owns audio unit, so should Google do that for them? There is a good parts and the bad parts of that. The good side is that audio unit is tightly coupled into the Apple platform. But on the other hand, it is kind of monopolized by Apple, so that only audio unit v3 is a feasible option for audio plugin format on AU v3. On other plugin formats such as VST3 or CLAP, they are DAW vendors. So should a DAW vendor define a plugin format? But the related question is there such a vendor on Android? There isn't. Actually, there was. I mean, there used to be another plugin format. The AP was not the first one. There was a company called Entrack, and they developed Audio Route SDK, and it was alive until around 2021-ish, but they didn't really hit the Play Store a lot. I think they only had their own plugins, so it didn't become popular, and they kind of stopped working on that. But in principle, anyone should be able to build a plugin format or more. A related question here is that can't we simply reuse existing formats such as VST3 or CLAP or Elevator but on Android? The answer is not likely, because they are basically designed for desktop, and we have to build something new ones anyway. But we haven't investigated a lot of Android things yet, so we will visit here later. Another related question is that can't we simply use Juice as a plugin format? The answer here is clearly no, because Juice API is in C++ and it expects static linking and it doesn't involve any ABI. And Juice is actually a plugin host and SDK or framework kind of library. It's not a plugin format, so it has a lot of features that if they become part of the plugin format, they have to preserve a lot of backward compatibility, which is not their goal. And also C++ ABI doesn't work for compatibility. We had some tough lessons learned from the VCB Rack project, which adopted C++ for the API, and now they cannot use Microsoft Visual C++ compiler on Windows to build their Windows binaries, because they started with GCC and G++, and they used MinGW. I mean, they still use MinGW, so that they have to live with the G++ ABI, not MSVC ABI. Okay, now let's dive into Android. It's a lot of it comes with a lot of pain points. I explain most of them one by one. The first thing is cross-process architecture. On desktop, DAWs can simply load the plugin DLLs, so that any plugin vendors can just publish their plugins and anyone can just download them and load on the DAW. But modern mobile platforms, it's not doable because they have isolated application storage set up, and they even have different user accounts for each application, so they have literally no access to other application directory. And we cannot DL open the plugin shared object libraries on Android. It is actually a restriction by Google Play Store, and the Android platform might be still able to load the library, shadow libraries from other applications, but I'm not sure it is still the case. So I wouldn't try to let you try F-Droid or other Play Store alikes to see if it's possible or not. So we can't use the DL open, so we have to communicate between the host and the plugin using IPC instead, inter-process communications. Android has a dedicated IPC foundation called Binder, and it goes down to the Linux kernel level. So especially in that Binder itself is capable of real-time priority inheritance, which means like if you are a DAW application which runs real-time audio thread, and from that real-time audio thread you can technically send the IPC message to a plugin which is in another application, but still the real-time priority is inherited to the Kali plugin. I said it already worked like that, but in fact it was only on principle, and Android imposes very tough restrictions on this real-time priority inheritance, so that we application developers can't really inherit this real-time priority, which means this Binder real-time priority inheritance is open only to the device vendors, I mean device driver vendors, and the platform developer, which is Google and other device vendors. So sadly, we can't really use the real-time safe audio processing feature on audio plugins on Android. iOS is different. Like they have a similar real-time priority inheritance system called XNU Turnstiles, and Audio Unit V3 has audio processor who has this feature enabled. It is explicitly allowed by the platform, so it is safe on their side. We are not yet. And even without this real-time priority inheritance, we should try to minimize the interaction between the host and the plugin in the audio processors, because they should always involve the context switches. So even on iOS you should avoid that as well. And this gives some principles on how to design the audio plugin API and behaviors. For example, callbacks from plugin to host within audio processing should be avoided. And some examples include that the clap plugins, a clap format has some extension feature called ThreadPro, which lets you run the micro-threading stuff on the audio processors. But it involves a lot of messaging between from the plugin side to back to host side, and it would involve a lot of context switches on IPC. AUV2 has some similar feature called the host callback and get beats and tempos. I mean, not really the similar feature, the similar drawbacks that involves the callback from plugin to host, which should be avoided in this principle. Okay, let me talk about GUI. Let me explain what audio plugin GUI provides in general, not just Android. It is actually more than just a GUI. For example, if you have some GUI plugin UI such as equalizer UI or something like OTT on this left side screenshot, then if you control some point on using a mouse, it will actually involve multiple parameters changed at a time. Without a GUI, you have to manually control every single parameter using the parameter slider or parameter knobs, and that's going to be somewhat complicated. Another reason for GUI is properties or non-float parameters, such as file name for used in the samplers or something like that. LV2 actually supports this kind of non-float parameters, and if you just support LV2, you can build some host applications that supports plugins that doesn't support GUI but still provides some string parameter or file path parameter, so that a sampler without GUI could still be useful on LV2 DAW. But it's a kind of a special case, and you usually don't want to build LV2 only DAW or LV2 only plugins. You would like to have multiple DAW that support multiple formats, or you want to build a plugin that supports multiple formats. And if you want to do the same for VST3, you will have to resort to the GUI anyway. So the last item is unmanaged presets, which is like actually a lot of existing audio plugins don't make full use of this presets API. I mean, every plugin format has something like presets API, so that the host can list the existing presets and user can just select a preset on the host side. But many plugins don't actually make use of it. When a plugin presets are supported, on the leftmost screenshot, this is from MDA LV2 application. MDA ported to LV2 supports a lot of presets, and this is an example screenshots from, I think it was MDA DX10, or there might be JX10 or others. All of those come with decent preset support, so you can just use your host to select the preset and it's loaded. But many other plugins, such as SurgeXT, which I showed on the demonstration, it comes with a lot of presets, but those presets are never exposed back to host level. So if you try to select a preset on the host, you actually see nothing, which is kind of bummer. But it is actually one of the biggest reasons why I wanted to support GUI. So I actually ported this SurgeXT a few years ago, but I didn't find it very exciting because it only gives me the boring sound, default sound. But after I made it possible to load the Juice GUI working and also bundled those factory presets within the APK, it started looking very fascinating and useful, because I can do a lot more with this plugin. Okay, let's talk about Android and the plugin GUI. I'm not going to talk about Android and the GUI in general, such as Android View, Jetpack Compose, or something like React Native or Flutter. They are different topic. I'm going to talk about the GUI on Android regarding the plugin UI architecture, how you can achieve plugin GUI. I think there are 4 approaches, and the first one is the Surface Control View Host, which is basically a remote view foundation on top of arbitrary surface view and other backend driven GUI rendering. It was newly supported starting Android 11, which is already a few years ago, but fairly new. And you can render Juice GUI or any Android view onto the host side surface view. That's what you saw when I was demonstrating the Juice plugin GUI. It is almost good, but still problematic in that we cannot really use text inputs, which is critical to some plugins. But fortunately, a lot of plugins don't really need text inputs. The IME is very essential to any language on Android, unlike desktop where only CJKB people care about. Because even if you type simple ASCII characters, you need some input methods show up, and you have to let user tap those characters on the screen. So you can't really enter any text if you can't use IME. The second option here is a web UI. I don't think I have to speak a lot about the web UI itself, because there are already some people talking about that, and it's a recent trend in audio plugin development. It wouldn't miss a lot of ability, but it still needs some JS DSP interaction through some dedicated web view. There are 2 other items such as notification bubbles or system alert window, but I don't find them very useful on plugin GUI. They are usable, but not really giving us very good user experience, so I would skip them so far. AAP supports the first 2 options. Regarding DUI on Android, it is still problematic when the screens are very small, which is true in general. Maybe this screenshot was not great because the plugin GUI looks almost fitting on the entire screen, but if you put everything, the entire GUI within the window, there can be very small controls that you can't really tap it on Android. There is no mouse cursor, so it cannot be very precise, and your finger is in the way. It's to prevent your verification by sight. You can't really see the controls under your finger. So instead of showing everything on one small window, what I do on an AAP instead is to show the partial GUI parts, and you have to scroll to other parts, which is maybe annoying and it's not really looking beautiful, but at least you can control the small controls. So there it is, the show everything versus show partial but make it controllable. I chose the latter so far. I have integrated a lot of Juice GUI plugin GUI stuff, and they come with a lot of pitfalls actually. So I had to patch around either JUICE itself or application sources. The most problematic thing is that the plugin runs as a service, not an activity. So services don't come with screen global display. So you have no access to the display from the plugin GUI, which runs as a service. Instead, we have to explicitly pass the parent UI window handle to the plugin GUI so that it renders on the host side parent display window whatsoever. The most popular problem I encountered was the JUICE pop-up menu, which is always rendered onto the global desktop, which works fine on the standalone application, but it doesn't as a plugin UI, so I had to patch around it. JUICE doesn't have synchronous dialog API on Android, while they exist on other platforms such as desktop. So we have to rewrite any synchronous dialog code with asynchronous version when we port to Android. JUICE also expects that there's only one JUICE activity within the application itself, because JUICE officially supports only standalone version of the plugin application. I mean, it doesn't even support the standalone application, but I made it possible somehow with one-liner patches. But when you try to get JUICE plugin GUI, as a plugin GUI, you need a few more changes to make it possible. So AAP JUICE, my repository for JUICE support modules, comes up with a handful of JUICE patches for different set of JUICE versions, because those JUICE plugins tend to use the fixed version of JUICE, because apparently it should be, and the JUICE implementation keeps changing, so patching wouldn't just work there, so unless they are versioned for each. So it's a lot of annoyances. Okay, let's talk about WebView UI now instead of native UI. Web UI is it should be very portable, and it should be very welcomed for Android plugin stuff. But the problem here is that the web view that is used to support the interaction between the UI and the DSP's part isn't that portable, unfortunately. For example, iPlug2 or DPF, they support web UI, but they don't support Android for web UI. iPlug2 actually doesn't support Android at all, so it's out of question. But even DPF, I have some DPF based LV2 plugins ported to AAP, but we cannot really use the web UI on Android. CMeasure is another interesting case. It does support Android, which is great. Like actually, I asked the developer Cesar at ADC Bristol last year if we can build a CMeasure patches for Android, and it was actually already done by Cesar in the past. And after I shoot the question to Cesar, 2 days later he messaged back to me like, it is already it is published on the latest GitHub release, preview release, and he was doing a great job, and I was amazed. But I noticed that their signature plugin example, Pro 54 something, it depends on the Choc Web View, and the Choc Web View doesn't support Android yet, so we can't use it yet. I hope to get it working at some stage. So another idea I had was commonizing and incorporating the web clap itself into AAP world, because web clap is based on the separate DSP and WebView UI, so it would be a natural fit for AAP as well, but it needs more time. Okay, next topic is file system stuff. We have no home directory or something like user share blah blah directory on Android, unlike Linux desktop. We only have per application data storage, and whenever we have to let user pick a file, we have to resort to the platform feature called Document Provider API or Storage Access Framework thing. And we need those local file stuff when we have to deal with presets or sampler files or some DSP scripts such as Reaper JSFX. I actually ported a plugin called YSFX, which is like yet another JSFX Reaper engine, JSFX engine, so that you can load arbitrary JSFX and it works like a plugin. So I ported it, and I had to bundle some popular JSFX repositories within the APK itself, so that we don't have to let user pick those arbitrary files. And to make it possible, we have to bundle some existing presets or preset files such and some sampler files if you want to bundle together as Android assets in the APK, and you have to extract them onto some file directory, files dir, which is per app data storage for Android, at the first run. Then you can seamlessly use these presets files or factory presets files or scripts just like they work on Android. Just work like on desktop. The last topic is threading requirements. It's kind of annoying. Basically, AAP avoids GUI thread requirement and synchronous API. It was actually not precise. We do have synchronous API in the AAP API extensions such as getState or setState, which should be asynchronous, but we have another layer, not the API itself, in the host helper library, and it is designed to be asynchronous. So with that part, everything works asynchronously in AAP world. If we expect the synchronous execution over IPC, sometimes goes super error prone, and I want to avoid that. There was some fabulous talk about this kind of stuff from Fabian Ren at ADC 24. One of his topic, among any other topic he brought about plugin differences in plugin formats, the behaviors, and good API parts and bad API parts, is that he was talking about plugin sandboxing, which is exactly applying to AAP as well, because AAP is essentially out of process. And he explained some deadlock scenarios over there because of that were triggered by the synchronous requirements. So I want to avoid that in general. The clap also seems to have some issue recorded there, so that they should we should have some asynchronous API kind of stuff. So, but the issue is still open. There is not a lot of work done. And at this state, I'm quite unsure if VST3 or CLAP APIs are safe to reuse here, but I might be just, not really wrong, but I must be thinking too much. because Juice is actually designed to work like that. I mean, the state API or presets API, they are designed to be running on the synchronous main thread synchronously, and they are not really problematic at that aspect, so it might be a non-issue. Okay, let's go back to the topic we left so far. How about reusing existing plugin formats such as VST3 or LV2 or CLAP on Android? The answer I had was like not likely, and based on the threading requirement discussion, I would still think that having API by ourselves is probably safer, because the VST3 and the CLAP require too much main thread work on and they tend to block, and they have problems that there are too many tasks running on the main thread. LV2 and the CLAP require custom GUI types, so we have to define our own anyway. VST3 in fact too, but their API is abstract, so API was we can simply reuse it as well. Web CLAP brings in some interesting architectural thinking, in that they can build single DSP WASM module and one single web UI that can be used everywhere, which is very fascinating. And actually, even Android NDK team once thought of a unified WebAssembly as a native code ABI, which seemed really interesting and promising option. I mean, they did have that idea because they have to deal with too many ABIs such as ARM32, ARM64, IntelliX86, IntelliX64, and now they have RISC-V. Oh, there are too many. So they wanted to resolve the issue by adopting WASM, but the issue was closed as not planned because they don't have a lot of engineering resources, I guess. So I'm different. I might add that feature later, but it's still like just an idea. And adopting this web CLAP and web UI practically means we are GUI-less nowadays, because there's almost no open source plugin that makes full use of WebView UI yet. All those Juice plugins are Juice GUI Basics or Juice OpenGL whatsoever, sadly. And if we integrate JuiceM script and fork, it might become usable option again, but it also involves a lot of work, so at this state I don't plan to work on that. So I find that the AAP defining its own APIs may be more practical. How AAP deals with extensibility is an interesting topic, I think. I only define the extension functions within as a binary protocol, basically. And in particular, I don't define those extension functions in the binder APC in AIDL. The AIDL only supports something like create, prepare, activate, and deactivate, which are LV2 term for start processing and stop processing, and the process function, and another general function called extension. I actually have a few more extension function, AIDL functions such as add extension, that kind of stuff, but basically the API is limited, because if we add more extension functions on the AIDL, that essentially means API breakage, because anything generated by the binder AIDL toolchain could be binary ABI breakage. So I define those extension functions using the binary protocol instead. The binary protocol means like the set of arguments packed just like protocol buffers. Or if you are familiar with MIDI CI, it works like MIDI CI actually. The transport is actually either a binder or a binder packages or MIDI 2.0 CCX messages on a process function. So it works like the MIDI CI properties functions. Like, for example, the AAP state extension can work like get and state device state MIDI CI properties, which is very interesting thing, I think. And actually, I designed this protocol before MIDI Association published these MIDI CI properties. So when I found them, I thought like, wow, they look like my AP stuff. So AP is almost feature complete, like I showed on some plugin host, which looked like a DAW, but still misses these things, such as the polished and stable API so far. But we have AAP LV2 and AAP Juice to build the host, the plugins, and for host we have AAP Juice hosting side stuff. I don't have any LV2 plugin host ported to Android because there's no such reusable application portable enough to Android. Or you can use my hosting library called UAPMD that I showed the sample dog fooding application. It is essentially a library which is not like Juice, so you can simply integrate it into your application. And we really need some useful DAW or that kind of host. UAPMD on Android is as usable as you saw, but it's still crashy and it's kind of unstable. It's more like an experimental host stuff, but it still supports like 6 I could play some music with 6 tracks without glitches with some certain buffer size. So I think it's usable. If someone builds a DAW on top of it, I would appreciate that. We also don't have any released applications on Google Play Store yet. And how I distribute those plugins and host instead is that I have some dedicated installer application that runs on Android, and it pulls all those released binaries from my registered AAP plugin repositories and host repository. Or you can use application called Obtainium, which pulls, which does exactly the same stuff, but it's designed for not just for AAP. But I still hope that I publish those plugin ports to the Play Store soonish. But I avoided that because they are crashy and I don't want to collect a lot of 1-star reviews because it's just crashy. But they should be published really. And lastly, I don't have any business plan, which is a very important thing, I think. But I didn't do anything so far. So if you have any idea how I build a business or work together, let me know. Okay, time to wrap up. So I discussed that we need plugin formats that respects Android as the first citizen, and AAP is the only one so far. And Android has its own difficulty to achieve the plugin features in that it lacks good cross-process architecture. It has to deal with GUI. GUI is annoying. File systems are annoying, and asynchronous API is needed. And if you want to build something like AAP, the plugin format for Android, you will have to deal with these kind of issues. That's what I wanted to share throughout this session. Okay, thank you so much. And if you are curious about the AAP project itself, please have a look at AAP at Siena/AAP core for further details. I also share a lot of screenshots and list of plugin ports over there. And we have a local music program, music developer, audio developer meetup thing in Tokyo, which is usually offline but sometimes online. And if you are curious or you want to join the group, please have a look at this musictechcompass.com. Compass.com has a lot of other similar community, and there are tremendous amount of communities in Japan. Okay, thank you so much.